And hello all, Mr. Callan here to talk to you about Algebra 1's final project. You can see on the left what the recording paper looks like. Basically, you'll do a couple steps at a time, whatever your teacher asks you to do, and then your teacher will put their initials right next to it so you know you're in good shape. Step by step, day one, you're going to analyze data, choose two variables. Step two, you're going to make your own scatter plot with the variables that you've selected. Step three is going to be writing an equation. You're going to have to find slope, y-intercept. Then you're going to use Desmos to create your own. Now, as a reminder, when you pick data, sometimes it works and sometimes it doesn't. So for instance, if you look at the graph on the left, there really is no association. What is it? Is it negative? Is it positive? Well, there appears to be, with this data set, no association between hours of TV watched and the age. You could say the same about the graph on the right. A student's score, whatever that score is, not the best of labels, and their shoe size. There does not seem to be a positive or a negative association involved with that. Now, we may or may not have skipped a lesson on something titled correlation coefficient. Long story short, there's this R value quantity, and the closer it is to 0, the weaker it is to a linear association. Meanwhile, the closer it is to either positive 1 or negative 1, the better it is. If you take a look at R as 0.95, you can see pretty clearly that you should be able to draw a decent line of best fit that really does do a good job predicting the relationship. Meanwhile, the one in the middle, R is negative 0 and 62/100. Okay, once again, you could draw a decent line of best fit through there to describe what's going on. Now on the flip side, if you look at the very right, if it's close to 0, like R is 0.13, you can tell pretty quickly. There's no positive relationship here. There's no negative relationship. It doesn't appear that these two variables are associated. Now that's important because when you select your two data, you might choose, if your teacher asks you to type it in first into the Desmos calculator. So for instance, I took a look at baseball data comparing strikeouts to runs. Now you would have thought that the more a team has strikeouts, the less runs they would score. But if I were to show you way down here on the right, way down here on the left, I'm going to go ahead and make that a little bigger. If I looked at it and I tried to draw a line of best fit, I asked the computer to, the correlation coefficient R equals negative 0.05. That's almost 0. So there is clearly no good relationship, at least in baseball, at least in this data, between strikeouts and runs, which surprised me. So please be careful choosing your data and make sure that it looks like a positive or negative relationship. So you're going to choose that. Your teacher's going to sign you off on that. Next up is you making your own scatter plot. And it's not going to look exactly like what you see in Desmos. Now the first thing you're going to be asked to do is label it. For instance, I'm going to show you an example comparing the overall grade to missing assignments. Now one could assume a negative relationship here, negative association. As missing assignments increase, overall grade decreases, or you could have said it the other way. Overall grade decreases as missing assignments increase. Next up, you're going to have to choose a scale. Now what's important here is your scale might be different than what's on Desmos. For instance, if you have what looks like a good relationship, but the scale you choose doesn't even use 2/3 of the graph, not a good scale. You might have to extend it, make it bigger, or make it smaller. In my case, I'm going to go ahead and choose a scale of 5. Now you'll notice my scale of 5, I don't have to write the number every time, 55, 60, 65, 70, and so on. Now I tried a scale of smaller than that and it didn't quite get to, actually, come to think of it, that would have been my vertical scale with apologies. I just got to make sure, in fact, when you look at your table, ask yourself, what's the highest possible y value? And you can go past that, but make sure you get to that y value. What's the highest possible x value? You can go past that, but just make sure that you get to the highest possible x value with your scale. Again, your teacher will sign off on that. And next up is going to be writing your equation. In order to write your equation, you're going to need a couple things. This might look familiar to some of you folks. Oftentimes I ask my students to start off with the template. What's the slope? What's the y-intercept? So the first thing we're going to actually do, draw a line of best fit, then calculate the slope, use that slope to find the y-intercept, and finish by writing the equation. If I were to draw a decent line of best fit here, I notice a couple good points. And those points, this is comparing average rent for a one-bedroom apartment compared to average income in dollars per year. So I notice my 2 points for this particular case. One appears to be about $50,000 average income related to approximately $1,300. That might not be perfect, but it's pretty stinking close. Meanwhile, I'm going to go ahead now for my other point and choose what appears to be $55,000 with a rent of $1,500. Now those are the 2 points I'm using. If you remember a while back, we showed you a way to find slope. If you're going to find the vertical change, you need to subtract the 2 y values. Horizontal change, subtract the 2 x's. Often we included little bitty subscripts. Y value from the second point minus y value from the first. X from the second minus x from the first. But to find any change, we always subtract. Be very careful if you end up with some data that has negatives in it. So the first thing I'm going to do is I'm going to label my points. This I'll just call my first point. That one I'll call my second point. So the y value for my second point did not give myself enough space here. Let's try that again. Y value from the second point is about $1,500 for rent. Y value from the first point is $1,300, which means there seems to be an increase of $200 in the rent. But compared to what? X value from the second point, X value from the first point. A change in $5,000 of income. Now don't worry, because really you could go straight from here, pop that all into Desmos, and Desmos will give you your reduced either as fraction or a decimal. I'm going to change mine to a decimal because, hey, we're talking money here. It ends up being 4 pennies. And folks, with that in mind, I can now go ahead and substitute that slope in. But what is the y-intercept? Well, we have done work in this class, perhaps even in 8th grade, where if you have a slope and a single point, you can go ahead and substitute in an x value, substitute in a y value, and the only thing missing is going to be that y-intercept. So I'm going to go ahead and substitute in, I like to choose the smaller numbers, so I'll put in the first number, where 50,000 was my x coordinate and 1,300 was my y coordinate. Now we have an equation with one and only one missing piece. We can go ahead and solve for that missing piece. 4 pennies times 50,000 or 4 hundredths times 50,000 ends up being 2,000. And if I were to take away 2,000 from both sides, it ends up being a negative 700, folks. I know that's weird, but that is the prediction. Now, once upon a time, we talked about how all models are wrong, but some of them are helpful. This doesn't make sense. How can you have no income, but your rent is negative 700? Are they paying you to stay at that place? No, that's not the truth. That's not really what would happen in the real world. But This negative 700 is not there to tell us exactly what's happening in the real world. It's just meant to help us predict for the future. We could use this equation to make any prediction we want. Let me do one more example. This time I'm going to look at a negative association, a negative relationship. So this is real data from my students. I put about 30 students up there and wrote down their missing assignments, wrote down their overall grade. Because some students think, teachers, they're full of it, they don't know what they're talking about. So when I drew my line of best fit, I found 2 good points that it seemed to go through. And so my coordinates there are going to be, student way on the left had 1 missing assignment with an overall grade of 97%. Meanwhile, the student on the right had 22 missing assignments, an overall grade of 54%. So, again, we're going to draw a line of best fit, check. Next up, calculate the slope, find the y-intercept, and then write the equation. For the slope, remember please, we're going to subtract the 2 y coordinates. Y value from the second point is 54. Y value from the first point is 97. That showed an overall decline of 43. But follow me for a second. X value from the second point was 22. X value from the first point was 1. That was with 21 extra missing assignments. Now folks, this one was not a pretty decimal. So if I were to round this to the hundreds, it goes down about 2 points for every 1 missing assignment. That sounds nuts, but this was actually the case with my students. I'm going to go ahead and write in my slope. Now I'm going to use the slope and 1 point to solve for that missing piece, to solve for the... Now I can go ahead and just estimate it. It looks like 99, but let's actually find out what that missing piece is. You can use any x and y value that you want. I choose to use the easier numbers, so I'm going to use 1 for my x value, 97 for my y value. In this case, negative 2 and 5/100 times 1 would be itself. Now I'm going to go ahead and add 2 and 5/100 to both sides, which would leave me with something that was awfully close to my estimate. Now again, all models are wrong and some are helpful. Does that mean that a student who has no missing assignments will automatically get a 90? No, it's not an automatic, but it is a decent prediction, and it can predict how many assignments you're missing and what your overall grade would be. So, step by step, piece by piece, you're going to go through this example. I'll even show you this data and remind you how to enter the formula. I did want to show you that first example I had. You can see the R value over here on the left. R equals negative 0.05 was no good. Meanwhile, this was the next one I did. You can see that next one, R is negative 0.7, almost 71/100. That's close to negative 1. So that was a pretty good. Linear regression. If I clicked on this, you'll see the line pop up and you can see it's not perfect, but the world's not perfect. Last but not least, I thought I would show you this was real data that I had for my students. And to remind you how to type that in, it's been a while since we've seen this in Amplify. We typed in Y1 and then the little tilde, which should be in the top left of your keyboard next to the 1. You might have to hold Shift down. MX1, that doesn't look anything like it because we're missing the B. Now this will, let me get this out of the way, show you that negative coefficient, which was pretty stinking accurate for if my students, if there really is a pattern between homework and missing homework, that is, and overall scores. And then what we did was we actually typed this in. I'm not going to write negative 1 point, the whole thing. I'm going to round it, negative 1.58x plus, and then I'll use my y-intercept. And again, round that, 94.4, say closest to 6. And you can see that my blue line is right on top of my red line, which means here's what Desmos is giving me right here. That's all I have for you folks. Take care, do well, let's grow. If you have any questions, ask your teacher.